Hi, welcome to the Calculus 2 lecture series, and we are in the unit number 4, sequence and the series. And we are in the lecture number 16, and this is the second part, the second video for the lecture 16. So the first video, we introduced the definition of a series, and then we talk about the converging and the diverging series, and then we talk about the one we call this divergence test. Okay, so the second part of this lecture, we're going to talk about two specific series. So one is a geometric series, and another one is we call this a harmonic series here. All right. Okay. So now let's go ahead to go to our lecture notes and let's go ahead to get started here. Okay. So first, let's take a look at what is the geometric series here. All right. So the geometric series is a series, and they are different by ratios here. What I mean, so for example, this one here is if this is the first one is 3, then the next ones here I'm going to a 6. Then next ones here will be to the 12. Then the next number is 24. Then next number is 48, right? So in here, you know the second terms here will be the first term times 2. Then this will be this term times 2. And this will be this term times 2. And so this type of the series, we call this a geometric series. So like in fact, this term 12 will be the first term times what? 2 to the what? Seconds, right? 2 to the square. Then this terms here will be 3 times 2 to the what? To the third. So as you can see, each time the difference by factors. And these factors here, we call this the R's here. Okay, so now let's take a look at the way we define the geometric series here is, this is how do we define it? We say this is the R. So we have n is equal to 1 to infinity. And we have a to the r, the n minus 1. So basically, like we say here, is just like we talk about here, will be the a, then plus ar, then plus ar to the square, then plus ar to the cube, and dots, right? So each one's here, and were different by a ratio r. All right. So the r can be any numbers here, right? So the one thing here, we said here the geometric series, if it is a convergence here. So if this series is a convergence, then the R will be somewhere between 1 and -1. Okay, so it could be 1, cannot be 1. So if it's 1, will just be a plus a plus a plus a plus a, right? So that will be a divergent. So anytime the ratio is less than 1, and we know this will be the so then we know this will be the convergence. This is one very, very important and good characteristics for the, for this series also. And also we know this ones here will convergent to, we be able to physically calculate what is a convergent to. So this one we're going to be convergent to A over what is 1 minus r's here. So, to be easily to see. So sometimes I typically like to do like this way. So if I can factor the A and then to the inside, I can start with 1. So like 1 plus r plus r square plus r cube and go dots, right? So I have a better idea where, what is my R values here? Then I can plug it into the formulas here. So if I typically, if you factor the one out, and then the inside will be 1 plus R squared plus R cubed, then it's easier to apply the formula. So what is the harmonic series? Harmonic series is also a very popular series. It's the series we say summation. This is from n from 1 to infinities here. All right. So the harmonic series will just be 1 over n here. So this one's here, this is, we'll put it, this is 1 plus 1/2 and plus 1/3 and plus 1/4 and da 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 da. The reason why we call the harmonic is because if you plug in the strings with the length, right, 1 1/2, 1/3, and 1/4, and they produce a very kind of harmonious sound here. That's why we call it a harmonic series. And in here, one of the things we know about the harmonic series here, the harmonic series is a divergent series. Okay, so this is very important. The harmonic series is a divergent series, all right? Okay, oops, so here. Yeah, so it's a divergent series here, okay? All right, so now let's take a look here. Let's take a look at some more problems here. And so in here, and let's take a look at the first one is say the summation n from 1 to infinity, 2n to the 100 is a geometric series. So what is the A, what is the R? Okay, so let's take a look for these ones here. N is 1 to infinity, then this is 2n, and this is 100, right? So if you kind of plug in a few terms, so this will be 2 to the 100, and the plus, like this is 4 to the 100, and the plus A to the 100s, and da 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 da. Like let's say, what is A, what is R? Like I mentioned, typical, I like to factor out the things. So this is 2 to 100, and so first term will become 1, then the second term will become 2, and the third term will be 2 to the squares, right? And like this. So for this one here, I know by my definition, the front, this one will be my what? This one will be my A's, right? Okay, so I know my A's here is 2 to the 100. And what is my R's here? R is the 1 plus R squared. So those are my R's, right? All right, so my R is 2. So is this series divergent or convergent? This is a divergent. This one is a divergent geometric series. Why? It's because R is equal to what? Equal to 2, right? So we said the geometric series is only convergent, right? So when what? When R is between one, between the -1 and the 1s, right? So that's this series. Convergence is a no here. Okay, let's take a look at the problem number 2 here. So the problem number 2 here, we want to find the summation of this ones here. So let's take a look at this ones here. So this ones here, so let's try to write it into the few terms, and then let's take a look at what is the number looks like n equal to 1, so this will be -2 to the n, and then plus n equal to 2, so you will have -2 to the n, and to the 2's, right? And then plus -2 to the 9, and 3, da 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 da. Like I say, if I can factor the terms out, then that will be easier. So I factor -2, 9. Okay, so what is the first term you have? You will have 1 plus, then this one you can have -2, and then this is 9. Then the next terms here, right? So this one will be the -2, 9 to the square, then da 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 da. So for here, then just like from the definition, so I know this is what? This is my A's, right? And this is my A, and what is my R's here? So this is my R, right? So this is my R. So now this is a convergent because R is between -1 and 1. So I know by the formula, we know it's going to be equal to A to the 1 minus R, right? So let's plug in here. A is -2/9 and 1 minus R, so it's 1 plus 2 over what? 2/9 here, all right? So what here you have this -2/9. So this is 11/9. So you will get the number is -2/11, right? So this is -2/11 here. Okay, so this one is pretty simple. Okay, so now the next thing here is this one is a convergence. So we say, okay, this one's here. We say this one summation, right? So n from 1 to infinity, 6 to the n. I can put the 6 to the front. So this is a summation n from 1 to infinity, 1/n, right? Then I know what happens to this series. This is what? This is the harmonic series. So harmonic series is what? This one is a divergent series, right? So if a constant times the divergent series, the whole thing is still here. So it still is a divergence, right? So it's a no. Okay. Okay, so now let's take a look and other problems here. Okay, so now in here, this one's here, we said 2n over the 3n plus 1. All right, so like always, like if you can write down the few terms, maybe that will be helpful. So this one's here, let's see what is this one. So it looks like n equal to 1. So will be 2, and so it's 3 to the, so it's 9 plus n equal to 2. So this will be 4, and this is what, 27, right? And then go da 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 da. All right, so let's maybe write down one more term here. Okay, so maybe let's write down one more term. So this will be 8. So 3 is 81, right? So da 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 da. So now in order to use the formula, we need to know what is A, what is R. So factor the first term. So 2/9 out, right? You factor the first term. So this will be 1 plus. What is the second term left? Will be 2 over what? 2/3, right? Okay, so after that, what is this term? You factor 2/9 out, it's 4/9, right? So it will be 2/3 to the what? Squares, right? And then da 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 da. So then I know in here, so this is my A, and what is my R? This is my R. So then by the, by the formula, so I know the answer will be A over 1 minus R. So A is 2/9. 1 minus R is 1 minus 2/3. So this will be 2/9. And this is the 1/3, right? So what is the answer? So the answer is 2/3. So that means this ones will be converging to the 2/3 here. Okay, so dealing with geometric series is pretty easy to deal with, and the only things here is you need to be identify correctly what is the A value, what is the R values here. All right. Okay, so now let's take a look. The last problem is an application problem. And this is kind of interesting. Let's see how do we set it up. All right. Okay, so the problem number 5 is talk about in a race between Henry and a tortoise. Henry gave the tortoise a 100-meter head start. If Archie's run, so I guess the name of the tortoise is Archie, right? So the runs at 5 meters per second, and the tortoise, oh, okay, and the tortoise moves at 0.5 meter per second. Oh, I'm sorry here, I guess I get the names mixed up. So here should be the Henry's, right? So Henry runs, okay? So how far has the tortoise traveled by the time Henry catch up with him? All right, so let's do a graph here, and let's see how do we do that here, right? So here, this is Henry. Henry starting here, right? And he will give the tortoise 100 meters starting. So this is 100 meters here, and the tortoise is here. I hope I can draw like a good one. Okay, so when the tortoise reached the 100 meters line, then the Henry start to run. Okay, then after when the Henry run, then the same way the tortoise will start to continue walk, right? So here they are continue walk. So here, this is the tortoise here. Okay, so when the Henry start to run, so here it will run. So it will have this tortoise is going to go walk and the D1, right? And then it's continue. So that means the Henry need to catch up with this D1. Then here is going to a D2, and then the Henry will start to run the same distance D2. Then the tortoise will going to D3, and the Henry going to D3, and the till boom, he catch up here. All right. Okay. So now let's take a look. See here, right? So let's say the D1. So this is the D1 is the distance the tortoise travel while the Henry run this 100 miles here. Okay. So because the Henry's speed is 5 meters per second here. So because it's 5 meters per second here, right? So how how fast the distance D1 here will be what? It will be the first is 100 meters, right? And it will run 5 meters per second, right? So divided by 5, this is how long take the Henry to run. So it's 20. So from here to here, right? So it's 20. Is 20, the 20 seconds, right? So 20 seconds, but the tortoise, the speed is 0.5. So this is the total distance. So it's 20 seconds times 1/2. Okay, all right. So this is what? This is the 10 meters here. That means when the Henry run this 100 meters, the tortoise will be able to travel what? Travel 10 meters. All right. So now the tortoise is here, right? And in here, then the Henry need to catch up again. So this 10 meters here, right? So now that's why the D2 is here. D2 will be the Henry catch up this 10 meters, right? And so the D2 will be the D1s, right? So it will be 10 meters, then divided by 5 again. So now it's only take a Henry 2 seconds. And then the tortoise only have 2 seconds to run. So it's 1/2. So that means this is 1 meter. That means in here, the tortoise only run to the 1 meter. And now for this 1 meter, and I'm going to catch up again, right? So now in here, based on this one, see here, the D2s here, if you, okay, so the D2s here, this one is D1, right? If you rewrite it, it will be the 5 over D1, right? Then times 1/2. So now you can see here, continue. Let's try to write it into a general term. So what is the general terms here? The general terms here will just be what is the distance previous one, right? So that means will be the distance on the previous one, n minus 1, just like d2, this is d1, and divided by 5 meters per second, then times what? 1/2, right? So then this one here will be the 10 to the d to the n minus 1. So now the total distances here will just be summation dn, right? N from 1 to infinities here, right? So here, if you do that, so this will be the 10 plus 1, and then you plug in the d3, then you get a 1 what? 1/10, right? Then you get d3, d4, then it's 100th, right? Then you da 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 da. So this is a geometric series. So now let's try to see what is my A, what is my R. So we factor the 10 out. So this will be 1 plus 1 over 10. Then what is this one going to be? This will be the 1 over what? 100. Then this one going to be what? 1 over 1,000 here, right? Da, 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 da. So now I know here, this is my A. And what is my R here? R is 1/10, right? Because this one's here is, you can write it into the 1/10 to the squares, right? And this one you can write is 1/10 to the cube, right? Okay, so now I will be able to know the total distance the series will cover. So the total distance, the total is going to run will be A over what? 1 minus R, right? So the A will be 10. 1 minus R is 1 minus 1 over 10 here. So this will be the 10, 9 over what? 9 over 10. So this will be 100 over 9 meters here. So we know the totals here. So how far? So the totals is also travel 100 over 9 meters. All right, so a little bit more than 10 meters here. All right, so that is the, the introduction for the geometric series and the harmonic series. All right, so looking forward, and then next topic we're going to focus on, talk about the different the test to test the series is a convergence or divergence here. All right, okay, nice talk to you, and talk to you for our next video. All right, bye bye.